problem. This is a differential equation. This is another way of writing y prime or f prime. This is the derivative. This is a function for the slopes of the tangent lines at different points. So it's saying, hey, you know what? If you're at the point, this is a negative here. It's kind of hard to read. If you're at the point 1, 3, the slope of the tangent line there, well, is going to be negative 2 times 1 divided by 3. It tells you what the slope of this formula tells you the slope of the tangent line at each point. Okay, we're going to learn about this much more later this year. You don't need to know this all the way, but just recognize this is a formula for the slopes of the tangent lines. And if we graph all the slopes of the tangent lines, you know, it lets us see what the actual curve looks like. And what the curve looks like is called what the actual function is that has those slopes is called the solution to the differential equation. We'll be learning about this much more later. For now, all we know, and we're only doing one part of this free response question, is, let me back up for just a second. This comes from free response questions on the AP exam. They have a bunch of parts. This is one of the 3 parts, and this is the only part we know how to do right now, is to write an equation of the line tangent to the graph at 1, -1, and use it to approximate f of 1.1. So, we have a point, here's our point, and we need the slope to write the tangent line. To write the tangent line, we need a slope and a point. So the slope is going to come from the derivative. The derivative tells us the slope. So it's going to be negative 2 times 1, that's the x value, divided by the y value, which is negative 1. So this is 2. The slope is 2, and so the equation of the tangent line is y equals 2 times x minus x1 plus y1. Okay, so there is our tangent line, and we need to approximate f of 1.1. So f of 1.1 is approximately equal to 2 times 1.1 minus 1 minus 1. 1.1 minus 1 is 0.1, 2 times 0.1 is 0.2, so 0.2 minus 1 is negative 0.8. So that is f of 1.1, and it's an approximation. All right, this last problem is tricky, and it represents, this is a problem that we have not learned exactly how to do in this class, and this happens on the AP exam, where you will get a problem that you have all the math you need to solve, but you've never done a problem quite like it, and that's okay. Okay, so we haven't done one just like this in class, but you know all the math you need to do it. If you haven't tried this yet, make sure you stop this video and try it on your own. Suppose that the graph of y equals 100 minus x squared over 400 represents a hill from level ground. So there's this hill. This must be y equals 100 minus x squared over 400. Notice I'm labeling my problem and figuring out what parts go with what. This is the hill. Okay. X and y are measured in meters. A 16-meter tower, TR, so this line segment from T to R is the tower. And it's 16 meters tall, so this distance is 16, stands on top of the hill. So there's this tower on top of a hill. So this goes to your geometry and whether you're able to label some things in a problem. Now it says to determine the equation of TQ, the line of sight from the top of the hill to the top of the tower to the hill. So it's this line of this tangent line. I'm trying to find the equation. Well, I need a point and a slope. I've got a point here. I need the slope. So I need another point. Well, I have this other point because I have this. I can figure out what point R is by plugging in x equals 0. When x equals 0, this is R. When x equals 0, 0 divided by 400 is 0. 100 minus 0 is 100. So this hill had a point at 0, 100. Okay? That's not a point on the tangent line. The tangent line point is t, but I know that this distance is 16. So it's 16 straight up from t. So it's 0, 116. That's point t. And so I can use that point along with the other point, the point of intersection. These are 2 points along the line. And from algebra 1, I can find the slope of the tangent line. 84 minus 116, y2 minus y1, divided by x2 minus x1, I'm going to use a calculator here. I don't feel like doing this in my head. 84 minus 116 divided by 80 is negative 0.4. And so the equation of the tangent line is y equals the slope. I should put the slope is this. Y equals negative 0.4 times x minus, I can use either one of these points because they're both on the tangent line. I'll use this one. And I can put this in slope-intercept form if I want. So negative 0.4 x plus 116. If I had used this other point, I would have come up with the exact same slope-intercept form. All right. Boy, so here's our tangent line. From the top of the tower to the ground, there is this P and Q, these points P and Q, that are blocked, the line of sight is blocked by the hill. So you can't see this part of the ground from the hill, and we want to know how big that distance is. Find the distance between P and Q. Well, I need two things. I need the x value of P and the x value of Q. We can use a very similar method on both of these to find the x value of P. Well, this is the x-intercept. It's where the y value is 0. And so I can take this hill function, we've got this hill function here, and set it equal to 0. 0 equals 100 minus x squared over 400. And we need to be able to solve this equation. I'm going to move this to the other side. So x squared over 400 equals 100 multiplied by 400. So 40,000 equals x squared. And take the square root of both sides. So x equals, remember when we take the square root of both sides, it's plus or minus. So x equals plus or minus 200 when we take the square root on both sides. Now, these are the two x-intercepts. One is over here, one is here. We only care about P, so we're going to use the positive one. So P is 200, comma 0. And we also need to find Q. We're going to use a similar thing. We have this equation of this tangent line. We want to know where the tangent line hits 0. And so we set our tangent line equal to 0. We want to know where is that y value, 0. And this is just a linear equation. I'm going to move the 116 over to the other side and divide by 0.4. I'm going to use a calculator. And that is 290. And so Q is 290, comma 0. So we've got 200, 0 and 290, 0. Let's reread our question. Find the distance between P and Q. The distance between P and Q is 90 meters. And that's it. That's the homework.